That's a little loud. Ethan, my friend, what's the title of this lesson? Lesson 2. All of you, if you want to, you can write a little equal sign, change in momentum. Impulse and change in momentum are the same thing. When I say find the change in momentum, Ethan, you know what I'm also trying you to find? The I word. Or if I ask you to find the impulse of something, I'm asking you to find its change in momentum. Okay? We can write that shorter. First of all, Caden, in the top of your green sheet, I can't remember whether it's top left or top right, what's change in anything? Final minus initial. And what's our symbol for change in? There's an abbrev. We don't say triangle, though, if we want to sound like a nerd. What do we say? A delta, okay? So if you're ever listening to NASA speak or something and you hear them say delta something, they're talking about a change in. Okay. Riley, what does it want me to prove? Can you read me this sentence here? Prove that.
Prove that change in momentum.
Stop. Change in momentum. Write that down. Keep reading.
Equals mass times velocity.
They want me to prove that that is the same as, I guess eventually, don't write this down, mass times change in velocity. They want me to get to there. Okay. I'm not going to ask you to recreate this, but Jet, again, because I'm teaching you a new concept, I always like to try and show you where it comes from. So, Caden, what's change in anything? What's change in anything? Caden, that's going to be your line for a while. Your agent has just called you up. You've got an acting part. And remember, there are no small roles, only small actors. This is your big break. What's change in anything? So I can write delta P as P final minus P initial. Momentum final minus momentum initial. Ooh, but Trevor, momentum is what times what? So I can write this as mv final minus mv initial. Final minus initial still. You okay with that? Okay, now we're going to get a tiny bit clever, Presley. Presley, is there an M in the first term right here? Is there an M in the second term right here? It is a GCF. I can factor it out. I can write it as M bracket V final minus V initial. Caden, what's change in anything? So what's final minus initial? More specific. Change it. I can write this as, you're right, delta V. I can write this as M delta V. And then on the left side, this would drop down like a domino. Riley, can you read for me the sentence that starts with the word prove, please?
Prove that change in momentum.
Stop. There's change in momentum. Keep reading.
Equals
Stop. There's the equals. Keep reading.
mass times velocity.
Yeah, it does. It does. Okay. So one way to find impulse or change in momentum is that, by the way, I usually use this version because that's easier to type on my calculator. It's pretty easy for me to go mass times V final minus sign mass times V initial. No brackets. It's just, I found I'm quicker at typing that. Impulse is defined as the change in momentum. And Julian, the impulse equation, I like to kind of think of it as a Swiss Army knife, in that, in the same way a Swiss Army knife has a whole bunch of tools that can save you time. Maybe they don't all work that great, but there's a bunch. The impulse equation is kind of that way. We're going to generate the impulse equation. It says, fill in the steps below to find the impulse equation. Nick, we got this. First of all, we're going to start with, it says, take Newton's second law, F equals ma, and solve for a. So Nick, if F equals ma, get the a by itself. Loud and proud. Well done. And Nick, from a couple of units ago, if VF equals VI plus AT, get the A by itself. I knew I could count on you. Well done. And then, Nick, I'm going to repeat myself not to make fun of you. Usually it would be to make fun of you, but this time is for an educational purpose. What does F over M equal? What does VF minus VI over T equal? Does this thing equal A? Does this second thing equal A? Then they equal each other. That was the conclusion I wanted to get to. What I can say is this. Apparently, F over M equals VF minus VI over T. By the way, Caden, another way to write VF minus VI would be delta V. Nick, is this a fraction? Is this a fraction? There! I'm going to get rid of fractions. I'm going to multiply the M up to here. I'm going to multiply the T up to here, so there's no longer fractions. And I'm going to get this. Force times time equals M. And you can either write it as delta V, or you can write force times time equals M V final minus M V initial. Because the M would multiply onto the V final and the V initial when it moved over to the other side. And then, Nick, what does it say to do? Substitute the result from the beginning of the... Okay. What was M delta V the same as? What was M delta V the same as? Impulse. Delta P, change of momentum. Those are all interchangeable. I'm fine with whichever one of those you said. Okay? This is the impulse equation. The impulse equation says this. If you want to find a change in momentum, an impulse, you can find it in two ways. One way is to go mass times change in velocity, and another way is to go a force times a change in time. We're going to get sloppy and stop writing the delta in front of the time. It's always a change in, but because this is a change in and this is a change in, it's kind of nice to have a change in there, but time by default is a change in. This is the impulse equation. What does it say? If you want to change an object's momentum, which would mean change its velocity, you need to apply an unbalanced force, because then it'll accelerate. Oh, and you need to apply that force for some amount of time. Oh, and the longer you apply that force, the bigger the change in momentum will be. Yeah, if you push on something for a longer time, it'll accelerate for a longer time. It'll speed up even more. Really what this does, Dan, is this combines Newton's second, F equals ma, and Vf equals Vi plus At into one big uber equation. Now this has three terms. We never use all three at once. So what this equation signifies is that a force acting for a time will change the amount of momentum of a system, which it will. Can you find this on your formula sheet? I think it's right next to P equals mv. Joseph, see it there? Okay. Everybody needs to know where it is. Can you read it to me in the order that I gave it to you on your green sheet? Because I can't remember which one I put first or second or third. What's the first one that I said? Okay, so I usually start with that. Impulse can be written as what? Yeah, I got that. That's the one I did next? Or, keep going. Oh, and by the way, the direction of the change in velocity will be the same as the direction of the force that you applied, which will be the same as the direction of the impulse. And again, a little note. Often I'll write that one when I'm writing it out by hand as MV final minus MV initial, because that's easier to type on my calculator. What you'll notice here is that, Chantel, this is sort of three equations in one. It's got three terms. We only use two at a time. So don't think you're going to write a two equal sign equation with three things. Which two will we use? It'll depend on what they give us and what they ask for. We'll figure it out. If it mentions or asks for force, I'm probably writing this one. If it mentions or asks for a V final or a V initial, I'm probably writing that. Oops, I erased it accidentally. Writing that one. Daniela, you might have noticed that we seem to be paying more attention to vector notation. I'm being much more meticulous. This is because in impulse and momentum questions, there are often changes in direction that we need to pay attention to. And yes, you anticipated where we're going. I saw you turn the page. So let's do this next question together, you and I. Okay? A baseball is pitched horizontally due east. So here's what you want to pick up. As soon as you see compass directions like north, south, east, west, or if you see the word forward and backward in the same question, or if you see the word rebounds or changes direction or turns around, anything that implies this question has more than one direction, you're going to need to decide as we go through which way you want to be positive and which way you want to be. So I see east, see it? And west. Those are trigger words for me. Which one do you want to let be positive? Doesn't matter, pick. East or west. Okay, so Daniela has decided to let east be positive. I want to be lazy, but organized. So I would do this. I would put a big plus sign in front of the word east. And then I would do one of two things. I might put a plus sign in front of the 38. I'm actually going to recommend you cross out the 38 and rewrite it with a big positive in front of it so it gets your attention. It takes 1 second, but that way you won't accidentally forget. And then what's west? Put a big minus sign in front of that, and I would cross out the 55 and replace it with a negative 55. I would also look for any forces and see if there was a direction for those. If there was a force to the west, it would be negative. I'd put a negative in front of it. Okay. What does part A want me to find? Impulse, you say. We have an abbrev for impulse. Impulse is change in momentum. What's our abbrev for change in? From our formula sheet. No, what's our abbrev for change in? Good. And what's our abbrev for momentum? No, P. Okay, don't overcomplicate it. That's the shortest way to write impulse. Oh, sorry, that's not. I lied. There is an abbrev for impulse. It's a capital letter J, but I've only seen some textbooks use it. I don't know if it's consistent. And I find writing this, even though it's a tiny bit longer than writing the capital letter J, I think this reinforces change in momentum. Impulse. Look at your impulse equation, Daniela, on your green sheet. It's that 3-in-1 equation. See it? Am I going to use the one with the force and the time in it, or I'm going to use the one with the mass and the change in velocity? Look at the question sorry? Because I don't see a force or a time here. Oh, and hopefully you were clever enough just to scan the units and figure it out. That's one of the reasons I told you it's worth memorizing units. So I'm going to write M delta V. You know what? I'm going to write M V final minus M V initial. Where'd that final minus initial come from, Caden? What's changing anything? This is your line. There it is. What's the mass? Daniela? V final? Don't say 55. No. V final? Don't say 55. Sorry, what's V final? Yes. Don't let me throw you off like that. Minus 0.144. What's V initial? Are you positive? Mm-hmm. Now, by the way, Julian is giving you a bit of a stink eye because he was going to let east be negative and west be positive. As long as you're consistent, Julian, throughout the whole question, we'll both end up with the same magnitude and we will end up with the same direction. We'll just have to interpret it, okay? What do you get on your calculator, please? What's the impulse? I think you can go 0.144 times negative 55 minus 0.144 times 38 equals, if you've got a good calculator. Your calculator might throw in, some of the calculators throw in brackets for you, but I wouldn't. I would just go like this. 0.144 times negative 55 minus 0.144 times 38. You get negative 13.392. I'm going to write negative 13.4. I'll store this on my calculator. Daniela, what's the negative telling me in, first of all, units. What do I measure mass in? What do I measure velocity in? So I guess it's mass times velocity, kilogram, meters per second. I think I mentioned the other day they're talking about renaming that an Einstein, which would probably be a capital E as an abbreviation, but they haven't yet. What's the significance of a negative? What direction is that telling me? So I would live with this, or you could say 13.4 kilogram meters per second west. Problem. We don't have enough letters in the English alphabet. A capital W is work and watts and west. So to show that it's west, a direction, there's two ways, two conventions. One is, don't write this down, to put it in square brackets. And I've seen some textbooks do that. The other way is to show that it's a direction, you put an @ symbol, like in your email address, and then you put the direction after the @ symbol. I use that one because that's how they used to do it on the old Physics 12 Provincial, and that was where I kind of learned how to teach physics, so it's a habit. Okay. Good. Yeah. Yeah. E is an abbreviation in capital E?
Yeah.
Oh, that's so on your calculator. It's actually not. If you look really, really close, the 5 will be that big. The E will look like a capital E, but it's shrunk. It's only half the height. And that comes from the way computers do math. It's a good thought, though. Hey, be obvious, folks. B. Where do you think this impulse comes from? What gave this baseball its change in momentum? I'm looking for another word that starts with letter B. Presley. Yep. Daniela, keep going. What does C want me to find? Yeah. Why did I say average force? I don't think it's constant, and we can't handle a changing force. Any of you ever see in slow motion a baseball hitting a bat? A video? Yeah. Dan, what do you notice? The baseball actually curves around the bat briefly and then kind of springs forward. That's why I don't think it's a constant force. I think it's way more complicated, but we can't handle that. So we'll just say, what does it want us to find? You're right. Don't write this down. Look up. Put your pencils down. I would, Presley, have no problem if you went, what does it want me to find? F equals what? F equals what? I would, don't write this down, have no problem if you did this. And then you said to yourself, did they give me a mass? Yeah. Did they give me an acceleration? No. Okay. A equals question mark. Well, VF is negative 55. VI is positive 38. They gave me a time. And then what equation could you, VF equals VI plus AT, and then get the A by itself. And if you want to do that, go right ahead. I will give you full credit. But what did I find in part A, Daniela? Can you give me a version of the impulse equation that has force in it? Get the F by itself. How will I move the T over? Divided by impulse? Like this? Okay. What am I trying to get by itself? The F. How will I move the T over? Divide. In fact, I'm going to say probably a lot of you, instead of writing this, could have gone straight to saying, I'm pretty sure here is another equation for force. Could you have done that kind of in your head? And do you notice how much quicker this is than going A equals question mark? VF equals VI plus A. You get the A by itself. This is a one line. This is what I said, Jet. The impulse equation is a lovely shortcut. Because F equals what? I lied to you when I said that was Newton's second law. Isaac Newton wasn't interested in acceleration. He was much more interested in change in momentum, in impulse. This is how he wrote Newton's second law. That's just for nerd trivia. Almost always nowadays we say Newton's second is F equals ma. That's become the convention. But when he first published it, he published it this way. But it is a force. Okay. What's the impulse? Disagree. Ah! What's the time? Well, it's 0.8. Ooh! There's a letter in front of the seconds, a lowercase m. Oh, that's milli. From your green sheet, milli is 10 to the what? From your green sheet, milli is 10 to the what? Is it negative 3? So, times 10 to the negative 3. What do you got? If you use your answer button, I get negative 16,740. I think if you use negative 13.4, you get negative 16,750. This is one of those rare times when you round, if you rounded to 3 sig figs, I'd be fine with a 7 there or an 8 there because it would depend on what value you would use. I would be a little grumpy with the 8 there because I would have said, why didn't you just use your answer button? It was sitting on your calculator. I led you right to it. You did more typing for less accuracy. But I'd accept it. So negative 16,700 and change newtons. What's the significance of the negative as a direction, Daniela? What direction was the force? Yeah, I need to retype these. I'm making a mental note. What I should have said next to A, what impulse in brackets, magnitude and direction. And what I should have said next to C, what was the average force in brackets, magnitude and direction. I forgot to include that. But you're going to start to see I'm going to get more and more fussy about now I want a direction because there was a change in direction. So I'm going to just write here, or 16,700 newtons at west. Alisher, what's D want me to find? Don't write this down. Look up. I would have no problem if you went, well, I don't know. I know VF. I know VI. I know. Except, Alisher, what did we just find in part C?
We found the average force.
There isn't by chance an equation that has force and acceleration, is there? There is? Get the A by itself, please. Oh, no, Trevor, this is your theorem. So, I would use this because I've got that number sitting on my calculator right now. I'll write negative 16,700, but I'm using my answer button. Daniela, was the mass 0.144? I'm going from memory. Yeah? And I get negative 116,000 meters per second squared. What's the significance of the negative? What direction is this baseball accelerating? West. But I just live with a negative. Full disclosure, I was trying to make up reasonable numbers. I even watched a couple of slow motion videos of baseballs getting hit by a bat because I was trying to figure out how long the impact lasts for. I think this is a little high. I think instead of 0.8 milliseconds, I think 8 milliseconds would have been better. I think the acceleration instead of 116,000 should have one less zero. And in fact, I think the force, my understanding of baseball bat usually applies between 5 and 10,000 newtons of force. Although maybe this is a major league slugger and maybe they can hit even harder than I expect. I don't know. Did you learn anything new? Strangely, I hope not. I hope that was all just being a bit clever. Do I have any football players here? Football player? Okay. What do you play, position-wise? Okay. I figured nose tackle, but no. This is going to explain an awful lot about why everyone in football stands where they are. I'm going to use you as an example later on. I won't tackle you or anything like that. Ethan, let's do this one together. What is the momentum of a 112 kilogram football player running due north with a speed of 3.6 meters per second? What does this question ask me to find? What's my abbrev from momentum? What's my abbrev? Did this say find the change in momentum? And by the way, I'm glad you made that silly mistake because every block has. Does this say find the change in momentum? Don't be telling me no delta. It's just saying find the what? Plain old momentum. What's my abbrev for plain old momentum? Look at your green sheet. It's so obvious that you're forgetting. Just no delta. Good. And how do I calculate it? Mass times velocity. What's the mass? What's the velocity? Direction. I'll just remember that. What do you get? You're going to get 400 something, I think. .403 units. 403.2. It's mass times velocity. So it's got to be kilogram meters per. Yep. Okay. Keep going, Ethan. What's B asked? Oh, if we add a direction, let's add a direction just in case. North. At north. Oh, that N. How do I know that N isn't newtons? Because it's after an at symbol. What does B want me to find? Stop. What's another phrase for impulse? Delta is a phrase for change in. But impulse isn't change in, it's change in something else. Right? No, just read to me what it says next to the title. What's another word for impulse? No, it's not what it says next to the title. It says a 3-word phrase next to the title. I hope you wrote it. What's another? Help me out, folks. What's another word for impulse? Change in momentum. You said change in. Change in what? Change in momentum. Then you said delta. That's change in. Change in what? So change in momentum. I would write that first because now my question is no longer blank. I feel better. Which version of change in momentum of the impulse equation am I going to use? Do you see a force or a time anywhere in this question? Okay, I'm not using that. You know what? I'm actually going to use Caden's version. Caden, what's change in anything? I'm actually going to write this as final minus initial. And the reason is I know the final momentum as a number exactly. What is the final momentum of this football player as a number exactly? Why 0? Bring to a stop. Is that okay, Ethan? And I know the initial momentum of this football player exactly what? Not the velocity. I know the initial momentum of this football player exactly, which is what? What? Say it again. Okay, and I'm going to be critical. 3.6, bad guess, right? That's a velocity, momentum. 403.2. Ethan, in your head, without a calculator, what's 0 take away 403.2? No. That would be 403.2 take away 0. What's 0 take away 403.2? What? Loud and proud. What? Kilogram meters per second. Or if you wanted to give that a direction, what direction have you let be negative? So, is that all right? Okay, I'm going to pause the video, make sure I don't forget to hit record again. Hit record for part C. So for part C, we said if we wanted to find the force, we could use F equals ma, or in our impulse equation, we could get the delta P over delta T by itself, get the F by itself, divide both sides by T, technically by delta T, but time is always a change in, plug and chug, and we would get that. Thank you for reminding me to press record. So, as I just finished saying, Jet, although we solved the previous problems using impulse, Really could have done it using Newton's second law, F equals ma, and Vf equals Vi plus At. So why do we bother with impulses and momentum? Trevor, it's one of our best tools in analyzing collisions, which we'll look at in the next couple of days. But there's already some questions that we can answer with impulse. Example 3. Turn the page. We're not going to do this experiment because I don't want to break an egg and waste food. We're going to do a thought experiment. I'd like you to imagine we have 2 identical eggs, same mass, and we drop them from the same height. One lands on cement and it breaks. The other one lands in a pail of water and doesn't break. Why does the second egg not break? Joseph. I am impressed because you went straight to the crux of the matter. I had a volunteer in my classroom this morning, and I mentioned to them all 3 of my classes this semester went straight to the aha, where previous years it's been like pulling teeth. So you said something about time. I like what he's saying. Here's what I'm going to do. Draw the line like this. On the left, let's call it the one that hits the ground. On the one, let's write H2O for the one that lands in the water. If we drop, Jet, we've turned the page now. You with me? I'm coming at you in a few minutes because you're zoning out more and more. If we drop them from the same height, will they hit the ground with the same velocity? Yes. We're going to call that velocity hitting the ground VI because that's when we're starting our experiment. What's VF for both of the eggs? 0. Okay. So do they have the same mass? Yes. Do they have the same V final? Same V initial? They have the same impulse. Yes? Because MV final minus... So I'm going to write this. Same impulse. So what was your explanation? What did you say, Joseph? No, you said a magic word starting with letter T. Okay. What's the version of impulse that has time in it, please, Joseph, my friend?
It's force.
Okay. So, for the water... much bigger time, smaller force to get the same impulse. For the cement, much smaller time requires a much bigger force. Is that okay the way I wrote it with large letters and small letters? That right there explains most of the car safety advances over the past 40 years. We started building in crumple zones. Cars that were built in the 40s, 50s, and 60s. At that time, auto manufacturers thought, we want the car to be indestructible because people want to be able to get into an accident and have the car be just fine. I had given to me years ago a 1969 Mercury Meteor. It was a big car. How big? This is true. We fit 39 people into it. Okay? We were hoping to get 43 because a Greyhound bus holds 43, and I so wanted to get the same number in my car as on a Greyhound bus, but we crammed 39 people into it. That car was designed, in fact, I did get rear-ended once, not a scratch on the car. Of course, that meant the impact got transferred to moi, right? So auto manufacturers learned in the 70s and especially in the 80s, they realized actually people would prefer the car to be damaged and their kids to be okay, which in hindsight is such a stupidly Captain Obvious, but it took a while for car manufacturers to figure that out. So what do? We build crumple zones. What do crumple zones do in a car crash? Increase time. Oh, which makes which variable get smaller? Okay, and F equals what? So what gets smaller in the force equation? Mass gets smaller?
Acceleration.
I've taught you, what does damage in a car crash? Speed? No. Force? No. What does damage to all of us? Acceleration is what does the damage. If you can reduce that, lives will be saved. I saw a hand up there.
Oh, yeah, that's what
Mercury Meteor. Like something dropping out of the sky, meteor. If you're doing a Google search, you'll see there are large vehicles. Large enough, for example, in the driver's seat, there is no way I could reach the far door without unbuckling my seat belt. It only had a lap belt, no shoulder belt at that time in the front seat, sliding across to reach the door. It was a big car. Jet, I'm going to hit you. I've had enough. Pause the video. Ooh, suspense on YouTube. So I wrote here, damage from change in momentum. What's another word for change momentum? Starts with letter I. Isn't caused by how much momentum is absorbed. It's caused by how fast the change in momentum is absorbed. All of you have gone from 100 kilometers to 0 kilometers per hour. Where? Driving off the freeway. And then onto an off-ramp. And then onto low heat. And then slowing down a bit more onto a major road. And then slowing down a bit more onto a subdivision road. And then slowing down a bit more into your driveway and coming to a stop. And none of you are bracing yourself as you're coming off the freeway or coming onto the low heat. In fact, most of you continue your conversations in the back. Sorry, stupid. Most of you continue typing on your phone in the back seat as if you would be talking to the person next to you in the back seat. I should have understood your generation doesn't do that. Most of you would have just kept texting in the back seat, wouldn't have noticed any difference at all. Right? So, does impulse do damage, Trevor? Say no. What does damage? How fast you absorb the impulse. And the big one is if you think about it in terms of force times time, smaller time, bigger force, therefore larger acceleration. Julian, I think you said mass earlier when I asked what changed. That is also possible. In a rocket, is the mass changing? That's a change in momentum and an impulse. We just don't have the physics to deal with that. You really start to need calculus for that. But there are versions of Newton's laws where A is constant and mass is changing. Absolutely. Absolutely. There are versions of Newton's laws where both A and mass are changing. That's when you need calculus, when you have two things changing at once. But they're out there. So where has this occurred? It's driving off the freeway, right? Another good example or application of this, you'll often see motorcycle race tracks lined with hay bales. In terms of physics, what are the hay bales changing? Which physics variable? Time of impact. Yep, a little softer. Okay. When you're driving towards the pit bridge, just before right when you get on the bridge, right where it splits, what do you see right on the V where it, yeah. What do those do? Yeah. And that's a very low-tech, cheap solution. Those have only been around for about 20 years or so, but it was something people realized, you know what? It's a minor investment for a municipality. Every year, someone probably checks to make sure they haven't sprung a leak, but otherwise, it's basically cheap garbage cans with water. Easy way to lengthen time. Absolutely. In many sports that involve striking something, tennis, baseball, soccer, golf, players are told, follow through on the impact with the racket or with the stick or with the bat. Any tennis players here, for example? Nope. Okay, I played tennis. You follow through. Why would following through make the ball leave faster? Daniel. I thought you said something. Okay. Yeah. Why? Why would it give more momentum? Which variable are you changing? Time of impact. Yeah. So if I've lifted weights, I'm as strong as I can get. I can't increase force anymore. What I can do is try and keep the racket in contact with the ball a bit longer. Or the reverse of that. If you ever hit a drop shot in tennis, you pull back right at impact and you're trying to make time so small that barely any force gets transmitted to a ball. Or if you play, any baseball players here, when you bunt, you pull back. In fact, the best bunters can almost have magical control. They can drop the baseball right at their feet, forcing the bat catcher to scramble for it, or they can put it halfway between the bat catcher and the pitcher, so both players have to scramble for it, and now you've got two players out of position, but it's all about reducing the time of impact. Okay? So, as T increases, impulse increases. And since the ball's mass isn't changing, then the velocity's got to change. We're almost done. What has more momentum? A 1,000 kilogram car moving at 100 kilometers per hour or a 2,000 kilogram truck moving at 50 kilometers per hour? Yep. Your hint is It's a trick question. They're the same. Now, those aren't momentum units. If I go 1,000 kilograms times 100 kilometers per hour, I'll get kilometers per hour. But if I converted those to kilogram meters per second, you'll get the same number for both because they worked out to the same number to begin with. These are the same. Okay? In my football analogy, Ethan, again, a lighter player moving faster can also stop a heavier player moving slower. Yep. And again, the freaks are, oh, that's someone who's heavy and fast. We don't have much of an answer except let's triple team or quadruple team. It's why Derrick Henry is so tough to stop. Okay. Yes or no, does a moving object have momentum? Why? Trevor, momentum is what times what? Does a moving object have mass? Does it have a velocity? Does it have momentum? Good. Turn the page. Follow-up question. So if a moving object has momentum, does a moving object automatically have impulse? What's another word or phrase for impulse, Ethan, from the title of our lesson? So, does a moving object automatically have a changing momentum? When wouldn't it have a changing momentum? I totally disagree. I totally do agree. One person said constant acceleration. One person said if A is 0. One of those answers is right. Which one of those would give you a non-changing momentum? If A is 0, if you have a constant acceleration, that means there's an unbalanced force. That means you're constantly speeding up, which means your momentum is changing. But if A is 0, you have a constant velocity. Oh, if A is 0, what's the net force on you exactly as a number? And so in my impulse equation, do you know what F times T is? If F is 0, what's 0 times T? No impulse. So, does a moving object have impulse? Only when accelerating. If it's at a constant velocity, it has momentum, but it's a constant momentum, not a changing momentum. 2 more, we're done. When you jump from your lab table to the ground, if I'm not going to do that, but if I had you jump from the lab table to the ground, yeah. Oh, I thought you were asking a question. Let me finish the question. Why do you bend your knees when you land? Yosef. As T increases, which variable gets smaller then? You'll laugh, but this is one of the reasons we build playgrounds for 4-year-olds, 5-year-olds, and 6-year-olds. Remember when you were that age, a playground was just the best thing on earth. You could spend hours and hours there. But in that rough and tumble, what you're actually doing is figuring out the laws to move your body around safely. And maybe your first jump ever, you landed stiff-legged and it hurt. And then you watched people around you, your peers, oh, they're bending their knees, or you figured it out yourself. Now you don't have to tell yourself to bend your knees. If you did have to jump off of something this high or higher, probably without even thinking about it, as you landed, you would bend your knees and maybe even roll. All about, can I accelerate the time of impact? Last question. I know I've been talking a long time. Danielle is yawning. Which of the following situations is more likely to knock out a boxer? Leaning back while taking a punch, or leaning in while taking a punch? Why? You're correct. When you're leaning in, I think you're decreasing the time. I think backing up, you're lengthening the time that the glove is in contact with your face and thereby reducing the force. Leaning in, you're bringing the glove to a stop faster in less time. So again, time decreases, then the force, because in both of them, you're stopping the glove with your face. But if I can stop the glove with my face and make it last longer, smaller force. What's your homework? Every question. Don't worry, a lot of them are conceptual. Okay? Not all of them, but a lot of them are. I'm going to continue this theme tomorrow. If I really cracked the whip, I might be able to get our test in by Thursday before Christmas, but I think I'm going to ease up a little bit, and I think we'll probably write the test around the first Friday when we return, because we come back on a Tuesday. We'll do a little bit of review and one more take-home quiz. I'll probably start the next lesson, next unit on the Thursday, and we'll write the test the first Friday when we get back. Okay? So you won't have homework over Christmas, but I would say it might be worth somewhere around New Year's to look at your notes or read through your notes once more to jog your memory. My angels, there's 12 minutes left. I don't want to see you staring at phones. You can work on the momentum homework from 2 days ago or today's homework.